Okay, so I've made a simulation of about 100 asteroid games running in parallel, which you can see in a GUI. I'll show you that in a second. And each of the ships in each of the asteroid games is controlled by a neural network, the weights of which are initialized randomly when the simulations first run. The simulation runs for 30 seconds, and then each of the ships is given a fitness value depending on how many asteroids they destroyed during that 30-second period. Based on this fitness, each weight of the networks in all 100 simulations are put into a pool, and depending on the fitness of an individual network's weight, they will be picked proportional to that fitness. So this is called roulette selection, which is used quite often in genetic algorithms, which is exactly what I'm using here to train the network weights. So so two members from the population of weights picked at random but proportional based on their fitness. They're then crossed over, mutated, and basically this process loops through until there's 100 new network weights in a new set, and then these are applied to a new population, and the simulation runs again for another 30 seconds, and so on, with the general idea being that eventually the weights will converge upon an optimal solution for this particular problem, which is the game of asteroids. The inputs to the network are vectors to the nearest n asteroids. This is configurable through this configuration class here. So there's a load of variables that you can configure about the simulation. Some of them are to do with the network, and some of them are to do with mutation rate and stuff like this for the genetic algorithms, and some are to do with the simulation itself, such as like drag coefficients and max velocities, max rotational velocity, and so on. What else is there to say here? So the whole program itself is a JavaFX program, so that I can basically render the simulations to a GUI that the user can interact with. I've added some fancy stuff in there, relatively fancy anyway, for a little small project like this. You can click a button and see debug information. So for instance, it'll show you the vectors to all the asteroids that each ship's looking at. You can click on an individual simulation out of the 100 that are shown in a grid, and the whole screen will just become that simulation. So like the render coordinates are scaled up based on the aspect ratio of the screen and the resolution and whatnot of the window, sorry, not the screen. So what I'm going to do is run it and talk about some of the problems that I'm currently experiencing with this, as the ships are not converging on a solution. I've left them overnight one time and they still didn't converge. I'll maximize this now. So here you can see the 100 simulations have initialized, and all the asteroids spawn in at random positions in each of the coordinates of each of the simulations. So this could be one of the problems why they're not converging, because sometimes the ships will spawn inside an asteroid and just die straight away, or they might have an asteroid that's coming towards them from a certain angle really fast, just randomly, and that could maybe be that could kill a fit member of the population, basically at random. So that could be one of the issues. So yeah, I'll click on one of these and show you the GUI because it's kind of cool. So we'll maximize this one. He just died. The collision's pretty much pixel perfect. I'm using bitmaps and matrix transformations and whatnot to do the collision detection. Kept it simple shapes. There's a reset button, so I can reset everything. I'll just default everything back to random weights and just reset the whole simulation, clear all the memory and everything. You can click debug, and this will show you all the vectors as well as the fitnesses of each of the simulations. So unfortunately the simulation is currently locked with the frame rate of the rendering. So yeah, that's a bit of a design oversight, so I need to sort that out. So when you're debugging, it kind of really affects the simulation speed because it's having to draw all these vectors and also like calculate the vectors, because I don't sorry, that's incorrect. No, the vectors are always calculated because they're passed to the network. Sorry. But yeah, so you can see what's going on. Basically, the center of the ship has a vector to the center of each asteroid in the simulation. This means that the network's input count can change over time, or rather, it'll always have 20 vectors going into the network, but if there's not 20 asteroids to look at, let's say there's only 10 asteroids, there'll be 10 zeroed out vectors that are being passed as input to the network, which is probably another reason why this is failing, but I'm not entirely sure why, because I would have thought it would be able to train for that many inputs and just figure out the zeroed out inputs and what they mean, but unfortunately not. One of the other inputs to the neural network is, and I've faffed around a lot with this, I've like tried removing this or adding it to the network and it's not really had much effect, but one of the inputs currently to this network is the direction vector. And another input currently that I'm messing around with, which hasn't made much difference, is the current velocity vector of the ship, which can be separate to the direction vector, because the ship won't instantly stop. It has some drag applied to it, so it can be heading, say, in the up direction, and it can turn right without applying any thrust force in the right direction, if you like, and so it'll still continue moving upwards until the drag takes it back to zero. One of the reasons that I've made this video is because I've just recently watched a video by a guy called Code Bullet on YouTube, who's done a very similar thing to me. He's made a neural network and genetic algorithm sort of combo to learn the game Asteroids, but I just noticed that his inputs to his network are basically 8 direction vectors from the ship. So there's basically 4 vectors raycast out, if you like, from the ship, 8 vectors in the 8 directions, up, left, right, whatnot. And if they collide with an asteroid, obviously they'll be shorter. So he's got sort of a clamped input value, if you like, rather than mine, where I've got possible zeroed out vectors that are being passed, and that's not because they aren't. That's not because something's close. That's because there's nothing there for the vector to point at. So, yeah. If anyone has any ideas or finds this cool, then leave a comment, I guess.